welcome to my term project video. In this experiment, our main objective is to measure distance between an LDR and a light source. So we are required to do this with an LDR, and we are asked to design a circuit such that one of its output gives us a value that is related to the distance, so that we can find the distance by a formula. So let me show you our equipment that we are going to use. First of all, we are going to use a DC power supply, and we are going to arrange it to 12 volts. And we are going to use our digital multimeter on the appropriate scale. And we are going to use a 4.7 ohm resistor. And lastly, we are going to use our LDR, as you can see here. And so let me show you the light source. We are going to use our smartphone flashlight, and we are going to arrange it such that the LDR and the flashlights are on the same level. So let me start with designing our circuits. We are going to use the same circuits when we are calibrating our experiments and testing our values. So first of all, we are going to connect this 4.7 ohm resistor and the LDR in series, as in here. Then we are going to give a 12 volt power supply to these circuits, and we are going to measure the voltage value on the LDR with the digital multimeter. So let me do the connections. Here is our power supply. And these are the probes of our multimeter. Let me do the connection right. And the last probe is up on here. So we also put here a ruler so that we can measure the distance, and at point 0, when the light source is at 0, we have about a 2-meter distance between those. So we took measurements from 2 centimeter to the 25 centimeter upon here, to the 23 actually, and we are going to fetch this data, collect it, and we are going to fit an equation using it. Then right after we took our equation using MATLAB fitting, we are planning to test our data using exact the same configuration. Now we are going to collect our data using our configuration. When the ruler shows the 0 centimeter value, it is actually the distance between the LDR and the flashlight is actually 2 centimeters. So we start to take our data from 2 centimeters, and we are going to up to 25 centimeters. For each centimeter, we are going to enhance our distance by 1 centimeter for each measurement, and we're going to collect our voltmeter data or voltage data during this process. We have to go steady and slowly in order not to diffract anything, in order not to corrupt any data. We have to keep the angle between the LDR and the flashlight fixed, and we have to wait after we put our flashlight to a fixed distance in order to measure a steady voltage value. So that's why we wait after each centimeter for like 1 or 2 seconds. As you can see, as we increase our distance value, so does the voltage value. So we are going to see a directional relation between the voltage and the distance. But as we go more further, the voltage distance starts to increase more or less. So it's not going to be a perfect linear relationship. That's why we have to retrieve a more suitable equation for our relationship between the distance and the voltage value. And then we are going to test the equation. Now we will plot the data that we collected from our calibration step. We noted them and we inserted those voltage values in the MATLAB array, and we also created a distance array. Now we're going to plot them. As you can see, it's not a linear relation, it's more like a polynomial relationship, so we have to fit the data to an equation under the tools menu. You can see basic fitting. So on the menu that appears, we're going to choose an appropriate relationship, appropriate fit. So I considered cubic fitting seems to be a correct one. It's not actually so much important. You can also choose fourth degree polynomial or a quadratic equation, but I considered that cubic one seems to be a good one. In here, x values shows us voltage values and y value shows us distance. Now we are going to start our testing process. We are going to try our equation at 3 different points. At first, we are going to start where the ruler is at 10 centimeters. It is actually, as you remember, it was 12 centimeter value. So at this voltages, we should take a distance value that is around the 12 centimeter. Now we're going to put this voltage value in our equation. We noted this equation on MATLAB. Now we're going to run the equation with the voltage. So as you can see, we obtained a 12.16 centimeter value, which is a plausible value for our distance measurement device. Now we're going to use another centimeter value. We have to be careful about the angle of the light source. Now it is at 5 centimeters. This should give us 5 plus 2, 7 centimeters at the voltage 2.47. So we are looking for the 7 centimeter output. We're going to do the same process again, and we obtain the 7.01 centimeter value, which is almost excellent. Now let's try another value. We have to repeat this testing process in order to see that it actually works for different distance values. Now we are at 15 centimeters. Do the same process again. Insert the x value in our equation and see the output. And as you can see, it is 14.13 centimeters. All of these 3 centimeter values are plausible, I think. They are all under the error 10%. So it's a good device in our opinion. Conclusively, we saw that we can measure any distance, or we can measure some acceptable distances by using the terminal values of an LDR. Plus we need to calibrate our constructed circuits each time the experimental environment changes, because each time we change anything slight, we are going to obtain a different equation. That's all I would like to say about this project.